Good evening. We are team number 11, consisting of Shreyas, Khushi, and Arya, and we are here to present our project in BCSE 204L, Microprocessors and Microcontrollers course, and our project is Fire Detection System using 8051 microcontroller. Fire was discovered by man 500,000 years ago. With the advancement of human civilization, fire safety has become a prime concern. Fire may be caused by big or small losses. Fire may cause a big or small loss to damage. Fire may cause a big or small damage to properties like homes, shops, factories, etc. In 2021, India recorded 1.6 million fire incidents with 27,000 innocent lives lost. Along with prompt response to emergency situations, there comes a need for standalone autonomous fire detection systems. In fatal situations, early detection and fire alert will yield lesser loss of property and life. Fire hazards caused by incidents throughout the world, especially in developing countries where fire safety measures are precarious and often inadequate. Example Bangladesh. Although a number of advanced systems are used in practical scenarios, a reliable, easy, implementable, cost-effective autonomous fire system is not available in developing countries. Therefore, in this work, a low-cost, quick responsive fire flash smoke detection system and alarm system has been designed and implemented. The system is capable of sending alert messages via GSM network and activated sirens in the premises. As you can start.
Coming to the objectives of this project, safety is a crucial consideration in design of residential and commercial buildings. In order to safeguard against loss of life and damage to property, fire is a key element in safety considerations. The goal of this project is to create a microcontroller-based smoke detector that constantly checks for the presence of a significant amount of smoke and sounds a warning alert to the users to take appropriate safety precautions to contain the situation. Because the system's components are readily accessible and reasonably priced, implementing it won't cost a lot of money. Multiple sensors can be connected to the alarms at various places using a different kind of ports and all, using a single microcontroller as long as there are more pins available for numerous inputs and outputs. This project is also been designed to be further working version using the minimum hardware at the lower level of processing. These systems are directed at specific applications. Our main objective is to design a fire and a smoke detection and prevention system that would fulfill the following objectives, which is to indicate the fire erupted, to indicate the location where the fire has occurred, and to sound the alarm if the fire occurs when detected. Handing over
The
to
literature,
Arya again.
okay. Our literature review consists of these three papers. The paper written by Neelam Kumari, Kalyani Jal, Madhuri Rani, and others from the Department of Electronics from GIET India. My observation from this paper were the approximation methods that exist to provide estimates of smoke detection based on optical density, temperature rise, and gas velocity thresholds. The key points implemented from this paper were the microcontroller-based system monitors the condition of the system, and on receiving the fault at the controller, it activates a buzzer for information. The other paper was written by Tej Naga, Padmaja, Tevavat, Tejavat, and others. In this paper, an advanced smoke detection and temperature monitoring system is designed. The key points implemented were the LCD interfacing and GSM model interfacing, which will be part of the future prospects. Fire detectors and review design of an automated, quick responsive fire alarm based system on SMS, written by Omar Asif and others. This consisted of a review of existing fire detector types that have been carried out along with the development of a low-cost, portable, and reliable microcontroller-based automated fire alarm system for remotely alerting fire incidents in household or industrial premises. The key points implemented from this paper were design of fire alarm system, example the flowchart, and hardware design.
Now moving on to the methodology of the project. In a way to achieve the above objectives, the project need to be implemented as follows. The microcontroller is used as the heart of the fire alarm system that controls the entire operations involved. The fire alarm system is capable to sense the smoke which is emitted from the. For smoke detection, we have used an MQ2 flame sensor which detects carbon monoxide and even LPG and methane. If smoke is detected, then this sensor gives high output to the comparator, and then the comparator gives high pulse output to the microcontroller. And due to the fast response of this sensor, we can take immediate action on it and can stop further damage. With the help of this smoke sensor, we can detect fire or smoke. We have also added the temperature sensor to check whether there is an actual fire or no, because smoke can be even produced while cooking. The gas sensor output which we are getting is in an analog format, so and could not be given to 8051 directly. So we have to either interface analog to digital converter or use a comparator between the sensor and the microcontroller. In order to reduce the cost and reduce the circuit size, we have chosen to add a comparator to the circuit. We have also provided a buzzer for alarm indication. If smoke is detected, then the buzzer will be turned on. We also have used a 16 by 2 LCD display in this project. Coming to the hardware requirements, we have used a microcontroller 8051 and an MQ9 sensor, which is a smoke sensor, a comparator, an LCD display, a transistor, crystal diodes, resistor, and capacitor. We have also used buzzer, transformer, voltage regulator, and power supply. And the software requirements in this project we have used are Kale 8051.
LCD interfacing for the project is done in this way. We have used a liquid crystal display in this project for displaying necessary information. To send any command to the LCD, make the pin RS to 0. For data, make it to 1. Then send a high to low pulse to E pin to enable an internal latch for the LCD. For this project, the complete port 1 is used for interfacing. Buzzer, on the other hand, has two pins. One is connected to the supply and another with the microcontroller. When microcontroller will provide a low signal, the circuit will be complete and the buzzer will start alarming. The smoke sensor interfacing goes as follows. The smoke sensor is used for detecting smoke. The smoke sensor has 6 pins, 3 of which are connected to VCC, 1 is grounded, and 2 are connected to microcontroller through amplification circuit. The smoke sensor is connected to port 2, which will act as an input to the microcontroller and is transmitted to the microcontroller. The smoke sensor consists of heater internally, which ionizes the smoke particles. They will act as a charge carrier, so the voltage will build up at the output. This is a circuit diagram for our entire project, consisting of the microcontroller, the various sensors, and the LCD for output.
Yeah, coming to the coding part, here, again is our main program, and here we have the other functions. As you can see, our LCD is connected to the port 1. Complete port 1 is used for interfacing our LCD. So here in our main function, first of all, it calls our sensor data. That means it calls to this function. Here you can see as soon as port 2.0 is being cleared, our sensor is getting activated. So that means our project has detected smoke. That's why it will display in the main function. You can see it can display fire alarm. Otherwise, if it is not cleared, this function is called. Here you can see it is stating as normal. That means it has not detected any smoke. So, and here these and all codes are using for these and all are code for an LCD where we use our cursor and all. So this is for that. So here we are implementing it with Keel. So I'll show it up with Keel's software. So here we have a code for our project. Here you can see at the target, I have taken XTR as 11.0592. And we have selected on-chip ROM, on-chip XRAM. Then we have output selected to create hex file. And in our debug mode, we have selected simulator one. Hardware part will show after our presentation. So now I'm debugging it. So before executing it, we are going to we have I'm opening port 2 where a buzzer and sensor is connected. So now I'm executing it. So as you can see, this is our port which was connected to our buzzer sensor, and this port, that means this is port 2.4 and this is port 2.0. Here you can see in this code, our port 2.0 is connected to our sensor, and here port 2.4 is connected to our buzzer. So as soon as I'm clearing it, here you can see our buzzer port is set. That means our buzzer will be alarming, and our LCD will be displaying fire now. And again, if it is not sensing any smoke, it will be again set to set. Our port 2.0 will be set, and our buzzer will be switched off. So this is how our code works.
This is the demonstration for the fire detection system by Team 11. Here we have our code in KL 8051 and we are debugging it. As you can see, the code runs without any error. Then we run it. This is our setup where our LCD and our temperature sensor is connected. LED will be replaced by the buzzer. LED currently is connected to port 6 and port 25. By rubbing our palms together, the friction creates enough heat for the temperature sensor to detect, and as you can see, the LED glows, which will be later replaced by buzzer. After the heat has been removed, the LED stops glowing.
Now coming to the advantages and feature enhancement. First of all, we are going for advantages. We have early detection. That means a smoke detector microcontroller can detect smoke and fire earlier than traditional detectors, which we used to have, which can save many lives and prevent property damage. Customizable. A microcontroller-based smoke detector can be customized to suit different environments and specific needs. Connectivity. A detector can be integrated with smart home systems, allowing for remote monitoring and controlling. Low power consumption. A microcontroller can be designed to use low power and operate on battery power, making it more reliable during power outages. Cost effective. With the increased availability of microcontrollers and related technologies, the cost of designing and manufacturing a microcontroller based smoke detector is becoming more affordable. Future enhancement. First of all, AI. A microcontroller based smoke detector can be enhanced with AI algorithms to detect the fire patterns and respond accordingly. Machine learning. Machine learning can be used to improve the accuracy of the detection and reduce false alarms. IoT. IoT technologies can be integrated with a microcontroller-based smoke detector to provide real-time notifications and remote monitoring. Wireless connectivity. The detector can be enhanced with wireless connectivity such as like Wi-Fi or Bluetooth, allowing for easy communication with other devices. Environmental sensors. The microcontroller can be designed to monitor other environmental factors such as humidity and temperature, providing additional safety measures. So this is how our project ends. Thank you so much.
Thank you so much.
Thank you, sir.